Chapter 33, Fundamentals of Hydraulic and Aero-Hydraulic Braking Systems. Day 1, Video 6, Servo and Non-Servo Brakes. So get a little bit more in depth to the servo and non-servo brakes, how that works depending on brake design and then rotation of the vehicle. So here we've got a non-servo type wheel cylinder, braking hydraulic brake end. We've got the wheel cylinder here where the pressure is going to come in, and then it's got a piston here and a piston here, pushing these shoes into the drum. The return springs here. And then a pivot right down here that both shoes will pivot off of this point here. So this one would pivot out, this one would pivot out this way. So you make a brake application, we're going in a counterclockwise rotation. This shoe right here would now become our trailing shoe, because as I make that brake application, the force is pushing the shoe out and into the drum. It's going to pull it in, or that self-energizing effect. The friction is going to pull this shoe into the drum, and it's pivoting right here. So here's the anchor point. It's going to pivot into it. Our trailing shoe, all right, the rotation is still moving around this way, but I am moving the this edge of the shoe out into the drum, and there is no self-energizing or servo effect because it's pivoted down here, and this is where the energy is being exerted from the wheel cylinder into that drum here. So it's almost like that drum is going to try and push that brake back in. All right, so this would be a non-servo. I've got one shoe that energizes, the other one does not. So a little bit different drawing of that. Again, the anchor pin down here, shoes being forced into it. So a energizing effect would happen on the leading shoe, no energizing on the trailing shoe. Now we can have the self-energizing effect. We can change the design of the hydraulic brake or the drum brake, how the shoes move, and we can transfer anchor pins and then the motion of these shoes one to the other to create both shoes to self-energize. All right, so in here I would have that wheel cylinder pushing out, a piston pushing out here, and one pushing out here, and the anchor point of these shoes is on the top. So as I'm driving this way, so rotating a clockwise motion, the wheel cylinder would push this shoe, which now would become our leading or primary shoe, into the drum, and it would start to self-energize. It would pull in more into the drum, and then that rotational motion of the drum is going to cause this shoe to come out and then down and around. I've got a connection down here with my self-adjuster that's now going to start to shift this secondary shoe into the drum, right, until it's touching the anchor point here. So what we're really doing is combining these together with this rotational motion into one very large brake shoe instead of two small brake shoes. So just again, the drag forces and the way that shoe rotates and pivots around. With a servo style brake shoe, the anchor point is always here at the top. So even if I went the other direction, I would push out on this one, become my primary shoe, be pulled into the drum. The shoe would shift around down this way. Again, that linkage down here at the bottom would push the secondary shoe into the drum, and now we've effectively made two primary or servo shoes in this braking system.